Hello everybody, welcome back to the series where we're solving Codeforces problems in Python. In today's video, we're going to be solving problem 1857A, which is called array coloring. A bit of an interesting problem, a bit of an easy problem as well. Let's go ahead and see how we can solve this. Let's go ahead and read this problem first. You are given an array consisting of n integers. Your task is to determine whether it is possible to color all its elements in two colors such that the sums of the elements of both colors have the same parity. So what is parity? Parity is odd or even. Okay, that's what they're trying to say. And each color at least has one element color. So one thing that they're saying right now is you're given an array, right? And this array can be something like say 1, 3, 5, 7, 2, and 4. Okay. Now we have to color this array in such a way that both colors have the same parity. The sum of both colors have the same parity, and sum of both colors means sum of the elements of each color. Okay, the number of elements in a color does not have to be the same, it can be anything. Okay, so in this case, something of an example that I can take is 1, 3, 5, 7. Let's give this a color blue, and then we'll give 2 and 4 a color red. Now what is the sum of 1, 3, 5, 7? 3 plus 5 is 8, 8 plus 7 is 15, this will be 16. 2 and 4 is what? 6, right? And this will give you the answer what? This is also an even number, this is also an even number, therefore it's even. Okay, so that is what they're trying to say here, and this is just an example of that. And this is what they're saying. If it's 1, 2, 4, 3, 2, 3, 5, 4, this is how they're coloring this. So this is also odd. This would give you, no wait, sorry, this is even, and this will also give you an even number. Okay, where the sum of the elements is 6 and 18, both of them are even. Okay, so they give you a set of test cases. How this works is you get t, and then every time you have to input n and the list itself. So since we are dealing with Python, this does not have much significance, so we'll just be doing the list input by itself, but that's how you're going to get this out. Now let's go ahead and actually solve this problem. If you guys did understand the problem, let's go ahead and break this down further. This word parity is what is being thrown in this question. So they're saying you have an array, and you're going to be dividing that array. Divide array into 2. That's what they're saying, into 2. This is what coloring means. Divide the array into 2 such that the first part and the second part have the same parity. Okay, now something that I can do is, what are the laws of parity, right? And the sum, when you're dealing with sum of parity, not here, the sum of this half or this part and this part should be the same, right? So let me go ahead and write this a bit further, and let's talk about sum of parities. Okay, now tell me guys, what will happen, right? I have two parts, part A, correct, and part B. Right, this will be another color, maybe color A, and then this will be color B, and this will be color A. Okay, now let me take first case. What if color A is odd? In order to color this properly, part B, their sum should also be odd, correct? Similarly, part A, if it's even, we're saying part B will also be even. Okay, now when is a number odd? When it's only odd plus even, correct? Similarly, when is a number even? It's only when it's even plus even or odd plus odd, correct? This is what the laws state. Now can you tell me, using the same formula here, right, these are the only two cases that are possible, correct? Now odd, let me take the sum of the array itself. Odd and odd gives even, correct? So the sum of array is even in this case. Even plus even will also give me an even sum. So regardless of me having the same parity, no matter what it is, I should be getting an even sum of array. Okay, that is the main part of this question, and that's the solution really. If you're not able to understand why the array has to be even, the sum of the array has to be even, you're not able to understand more of this. Okay, so let's break this down further. Okay, so I'm going to have at least two elements, right? So let me take a case where this array is colorable. Okay, so This is a positive case. So either my numbers can be 1, 3 or 2, 4. Correct? So this is same parity. Correct? Same parity. In what cases are this not possible? Not possible would be a case like say 2 and 3. Correct? And or 2 and 7 maybe. So one odd and one even. Okay. Now these two are different parities, and this is how you'll color this basically, right? In this case, the sum of array is what? Is odd. Correct? This will be odd. Now, if you want to break this down further, and when I say if the sum of the array is even, therefore it's something that will be possible. Now, if you're able to understand this, or at least the inferences that we got from this experiment, we can say any number, any array, correct, can be represented as two elements. Can it be? Yes, we can. Let's say I have an array called x, y, z, a, b, c, d, e, whatever it is. Okay. What I'm going to do is I'm going to take all of these numbers and I'm going to represent it as something alpha. So I have gone ahead and made this into two elements. Yes. Similarly, I can also add this ended up and do something else for x also. So regardless of what my array size is, I can bring this down to two elements. Yes. And if I have two elements, and that let's call me a and b. Now a either can be odd or a either can be even. Similarly, b can be odd or b can be even. Correct? So all four cases where a is odd and b is odd, where a is even and b is even, where b is odd, a is odd, we'll look at all of that. Okay. So initially, let's say a is odd and then b is odd. The sum of the array is even. A is odd, b is even, the sum of the array is odd, right? And a is even, b is odd, again sum of the array is odd, and a is even, b is even, the sum of the array is even. Now in these cases, this is the same parity, a and b, correct? I can just give a one color and b one color. So any array, if I can bring this down to two elements, I can assign one color to one and one color to the other, right? So in both of these cases, this is not possible. Okay, and that is why I'm saying the sum of the array should be even. Now you might say, okay, I'm going to take an array where this necessarily might not be true. Can I do that? Well, let's try. Okay, so I'm going to take a case. So instead of saying, okay, you're going to say a is even, so we'll have something like 2, and then alpha would be something like 7, for example. You're saying instead of me combining and making this 2 as one color, why don't I take a different approach? Okay, let me try and break this down to you, and this I can expand into more elements, for example. Okay, I'll do something like 3 plus 4. Okay, now rather than me combining this into one color, what if I combine this into one color? Okay, then that will be 5 comma 4. Again, this case will happen where this is even and this is odd. So initially this is even, this is odd, but even here that will be an odd sum. Therefore, this array will not be something that can be colored. So regardless of how you rearrange this, it is fundamentally broken down into these. So any array you can represent into two elements, and these two elements have a total of 4 parity combinations. Whenever it's the same parity, it will always be even. Okay, that's why I'm saying if the sum of the array that you're given is even, then definitely it can be broken down, because definitely any array can be written into two elements if the array has more than two elements. Obviously, adding is something that we can always do. In that case, breaking that down, this is what all of that looks like. Maybe this is a bit of an over explanation. Again, maybe I've explained too much. A lot of this was not necessary, but I really want to make you understand why we're doing this. If you have any questions about what we've discussed till now, please let them know down in the comments so that I could take a shot in answering that. Let's go ahead and see what the code looks like for this. As I discussed, right, we're going to take t as int of input. That will be the number of test cases, and then we'll go ahead and do for in range of t. We're going to be looping for how many ever test cases are there. We'll take n as an input, which is not really required, but then let's take a list as an input. So list will be list of map of int comma input dot r strip dot split. Okay, so what this line means we've already discussed in a lot of videos. Maybe you can go ahead and see another video, and then what I'm going to do is I'm going to find the find the sum of the list. Now you can do two things, right? If you're just learning about coding, let's not use the inbuilt function of Python. Let's go ahead and create a total variable. We'll do for I in list. We'll do total plus equal to I. Okay, and then I'm going to do if total percentage 2 equal to 0, print yes, that is if it's even the total is, else print. Okay, and I'm going to go ahead and run this code. Oh sorry, this is supposed to say no, not odd. Yeah, I can see that this passed. And I'll just go ahead and copy this and go to this problem that we're just dealing with. I'm going to submit my code and show you what that looks like also. So I have to choose a problem, array coloring, and then submit. Now, yeah, you can see that it will get accepted. You see the problem is accepted. Right, and that's how you solve the array coloring problem. I hope this video helped you. The solution is really simple, but how we go there might be a bit difficult, especially if you're just starting out with competitive coding. Thank you so much for watching this video. If this video helped you, hit that like button. If you guys again have any questions, please let me know down in the comments. If you have any alternate approaches also, you can let me know down in the comments. Help yourselves out. Again, thank you so much for watching. I'll see you in the next video. Until then, bye.